Okay, now let's look at 5-7. Which of the following points is on the graph of this? Weesh. Oh my gosh. How do I turn it back? I know. Undo. Undo. Okay. So let's see, you guys. I notice all of these points are integers. So what I'm thinking is that there aren't too many choices. Because if I'm going to cube root a number here, it needs to come out to be an integer because all these numbers are integers. So, like, for example, if 12 were to go in for x, 12 plus 1 would be 13, and the cube root of 13 is not an integer. This wouldn't work. I'm not even going to bother. If 0 goes in, 0 plus 1 is 1, and the cube root of 1 is possible. So let's do it since we're here. This 0 plugged in for x here means that we have the cube root of 0 plus 1 and then minus 5. And 0 plus 1 is 1. And the cube root of 1 is 1. And 1 minus 5 is not negative 5, it's negative 4. So that one's also out. And then looking here, if x were 3, 3 plus 1 is 4, and 4 doesn't have a nice cube root. It has a nice square root, but not a nice cube root. So A is also out, which means by process of elimination, it's going to have to be B, but let's prove it. If I put a negative 2 in for x, I get the cube root of negative 2 plus 1, and then minus 5. And then negative 2 plus 1 is a negative 1. I still got a cube root, minus 5. And the cube root of negative 1 is a negative 1, minus 5. And negative 1 minus 5 is negative 6. So that one works. Okay, here is a function. Let's complete the table. Okay, so they're making me first figure out what x minus 3 is, then figure out what x square root of x minus 2 is. What's happening? Why x minus 2? I think they're trying to prove to you that you cannot add negative 3 plus 1 to get negative 2. I don't know. I don't know what we're doing, but they told me to complete the table, so I'll do it. If x is 3, 3 minus 3 is 0. Over here, 3 minus 2 is 1, and the square... What? That should be 1. Am I tripping, you guys? Are they trying to say that if you were to plug 3 in for x right here, 3 minus 2, that the square root of 3 minus 2 would be 0? Is that what they're saying? Or am I not understanding their directions? Because if that's what they're saying, they are definitely high. Okay, I can only do this the way I understand. So I'm going to cross their 0 out and put a 1. 3 minus 2 is 1. The square root of 1 is 1. I think they made a mistake. Just saying. So then over here, if I were to plug a 3 in, 3 minus 3 is 0. Ah, I know what they did. They meant for this to be a 3. I get it. They're building the function, you guys. Start out with doing x minus 3. Then let's square root x minus 3. And then let's add 1 to it. Got it. Got it. They made a mistake right there. I think that's a typo. That should have been a 3, not a 2. So, let's go. 3 minus 3 is 0. Square root of 0 is 0. And 0 plus 1 is 1. That's how that works. And now with a 4. 4 minus 3 is 1. Square root of 1 is 1. And 1 plus 1 is 2. Let's go with a 7. 7 minus 3 is 4. The square root of 4 is 2. And then 2 plus 1 is 3. All right? Okay. I guess I'll find out who watched my videos when I see who managed to complete the table correctly, because otherwise it doesn't make any sense. Now, describe how g of x is a transformation of its parent function. How is it a transformation? Well, we've got ourselves a minus 3 right there, which means that we are going to the right 3, namely a horizontal translation in addition to a vertical translation. That one is the up one. That's what's happening. And now graph g of x on the same coordinate plane. No problem. I just have to go right 3 and up 1 on every single one of these. Let's go right 3, up 1. Let's take this point and go right 3, up 1. And then let's take, actually, we can even graph it with this table. So when x is 3, y is 1. When x is 4, y is 2. And when x is 7, y is 1, 2, 3 right there. So you could graph it using the transformations or the table that we already worked hard to make. So why not use it since we have it? Okay, now we're graphing from scratch. Let me show you what I do. If it helps, remember 0, 0, 1, 1, and then 4, 2 are points on the original parent function. This is our original y equals square root of x. So what do we have? We have the original y equals square root of x, except we have moved left 4, plus we have a vertical stretch by 2. So let's put it to use. Let's go. We're going to go left 1, 2, 3, 4. We're going to begin here. And then instead of going up 1 over 2, up 1 over 1, we're going to go up 2 over 1 because we're stretched. All right? And if you want to keep stretching, this one that's gone here, honestly, I'm okay with just doing this at this point. But let's get it right. Let's see where this point ends up. This point, that's 1, 2, 3, 4 over from the starting point. So 1, 2, 3, 4 over from the starting point. It goes up 2, but stretched by 2 means it's going to go up double that. It's going to go up 4. Oh, no, just kidding. Hold on. From here, it's going to go up 4. Like that. That's what we have. That function. Okay, now let's go look at this. Let's see what our original parent function, cube root function is. It's at 0, 0, and 1, 1, and negative 1, negative 1. And then after that, you got to plug in an 8 to cube root and get 2. And a negative 8 to cube root to get negative 2. So you start out high and mighty, but then it mellows out real quick. That cube root brings it down to earth a little bit. Can't get a big head. Okay, now, what are we dealing with? We're dealing with this with a horizontal reflection and also a vertical translation or shift down to. So this point will reflect horizontally to be there, and this point will reflect to be there, and that point will reflect to be here, and this point will reflect to be here. And we will get this. And then now, we also need to go down 2 though. So all these points down 2. This one, down 2. that one down 2, that one down 2, that one down 2, and okay, the solid blue graph is our final product. Okay. Now we have a square root. Remembering that this is what it does. Okay, and at 9 it's at 3 if you want to get more specific, because square root of 9 is 3. What's happening here? We are going up 3, we're going right 2, and we are doing a vertical reflection. Remember that when we do transformations, shifts are last. Please remember that. Shifts last. Shifts are addition and subtraction, and PEMDAS makes them be last, okay? So the first thing you must do is everything else. In this case, just a vertical reflection. So this point stays here, this point flips down, this point flips down, this point, if you had it, flips down, and we have that. And then now if I go to the right 2 and up 3, move every point, right 2, up 3, right 2, up 3, right 2, up 3. Okay, I don't need that one. That one went off the graph. Doesn't mean I can't though. I'm like annoyed at myself for giving up. Up 1, up 2, up 3. Okay, there it is, the final graph right there. Okay, the graphs of the function c of x and q of x both go through those points. Okay. Write a possible equation for c of x so that it is a square root function. Then sketch the graph of c of x on the coordinate plane. So let's go and see how we want to do this. If this is going to be a square root function, I mean, it can just be that. Easy peasy. I mean, you could get creative and make it go this way if you want, but honestly, I like keeping it simple. So this is a normal square root function that starts here instead of here. So it's gone 1, 2, 3, 4 to the right or left, and then up 2. 4 left, up 2. So we have the square root of x. Okay, the 4 left is going to be a plus 4 with x, and the up 2 is going to be a plus 2. Okay, and now they want it to be a cube root function, and you know what, you guys? The cube root function does exactly what a square root function does in the very, very beginning. Do you guys believe me? Let me real quick flip it back to the old one. Look at this. Look at this cube root function starting at 0, 0, and then going up 1 over 1 to 1, 1. And then look at the square root function starting at 0, 0, and then going up 1 over 1 to 1, 1. These first 2 points are the same. It's the only ones that are the same. However, they are the same. So if I make, if I make these same 2 points just be a cube root function instead of a square root function, then it still just went to the left 4 and up 2, and it's going to have the exact same equation, just with a little cube root instead of a square root. All right. Okay. Ooh, they got fancy on us. They want me to transform one or both of these functions, the square root and the cube root function, so that they share 3 coordinate points. Now, I told you just now that they share 2 coordinate points. As they are right now, they share 2. They share 0, 0. They share 1, 1. But we need them to share another one. So the square root function, let's see what they do from there. 0, 0, and 1, 1 they both have. And then from there, the square root function goes 4, 2, whereas the cube root function goes 8, 2. So it's a little bit like, it's a little bit like if I stretch the cube root function. See, the cube root function would go like this. And the square root function would go like this. It's a little bit like if I stretch the cube root function. No, because then if I stretch it, it won't go through that point anymore. Oh, but I could transform both of them. You know, you guys, they kind of got me. I can't think of this. I can't think of it right now. I feel like I'm on the spot. Could I stretch the square root? We need the square root and the cube root function to be the same, to have 3 solutions when we solve this equation, essentially. We want 3 solutions. So I can add things all around as long as when I solve, there are 3 solutions. But how can there be 3? What if there was a plus or minus, and one of them was 0 and the other one had 2 solutions? But we're just talking standard transformations. You guys, I want to say it's not possible. If all we can do is shift, reflect, and stretch. Oh, wait a minute. Hold on. What if my cube root... Okay, you guys, you know what? I'm going to come back and start thinking about this. No, I'm going to do it. I'm going to do it right now. Let me see. I'm trying to think now. The cube root function can go through these 2 points like this and then go like that. That would be a negative cube root function. No, it wouldn't. Just kidding. That would be the cube root function moving up 1 and over 1. So -1 and +1. Okay, I think we might be getting somewhere now. So let me start this over. If I have my square root function going through this point, and then that point, like that, and if I bring my cube root function like this, and then that, it's shifted over 1. That could happen, right? And then let's see, what other points does the square root function have? The square root function has 4, 2, and then it has 9, 3. And then this cube root function would have 8, 10. 10 minus 1, 8. No, 9. 9 minus 1 would be 8. Cube root of 8 would be 2. And 2 plus 1 would be 3. Oh! That does it, you guys. That does it. Let me see. 0, 0 should be a point. 1, 1 should be a shared point. And then 9, 3 should be a shared point. Let's check. 0 would give me 0 on this side. And on this side, 0 minus 1 would be negative 1. Cube root of negative 1 would be negative 1. And negative 1 plus 1 would be 0. Okay, let's check 1, 1. 1 would give me 1. And then over here, 1 minus 1 would be 0. So cube root of 0 would be 0. And then plus 1 would be 1. 1, 1 works. Then 9, 3. Okay, plug 9 in there, I get 3. Plug 9 in there, you get 9 minus 1 is 8. Cube root of 8 is 2. And then 2 plus 1 is 3. Also comes out true. And, God, I really want to do it, you guys. I really want to solve this algebraically and get 3 solutions out of it. 0, 1, and 9. Because that would be so fun. But it's a nightmare. It's a nightmare. I'm going to do it on my own time just for fun, okay? All right, let's move it along, you guys. But this is it right here. Transform one or both of these functions. I'm not going to transform f of x. F of x will remain f of x. But g of x I will transform. Let's call it h of x. And it's going to be this right here. Cube root of x minus 1 plus 1. Okay. That was a really good question. I want to meet the people who come up with these questions. I think we would have so much fun hanging out. Write the inverse of each function. Sweet. Okay, we start with x, okay? What's the first thing happening? Cube. And then what's the next thing happening? Plus 1. So now we reverse it. X. Let's do the opposite of that. Minus 1. And let's do the opposite of the cube. Cube root. And there's the inverse. Cube root of x minus 1. And now let's do it here. Okay? We're going to start with x. What's the first thing happening to x? Plus 2. And then what's happening to x plus 2? It's cubed. Now let's start with x here and go in reverse order. Cube root. Cube root of x. Opposite of plus 2, minus 2. Cube root of x minus 2. Alrighty. You're welcome to do this algebraically. You would just switch your x and y. And then you solve it, right? So get rid of that cube with a cube root. Cancel, cancel. Get rid of the plus 2 with a minus 2. Get the same exact answer we did. All right. That's it. Good luck, guys.